Good morning, children. Welcome to Government Educational Institution online classes. Yesterday, you learnt about Newton's first law of motion, inertia topic here. So, again, we are able to recapitulate yesterday classes here. So, inertia first law of motion, what it explains? Every object remains in the state of rest or in uniform motion unless an external force act on the object here. So, inertia is nothing but that is not accepting the change here. So, for the continuation process here, inertia is a measure of mass here. So, if you take two wooden blocks and it is to be placed on a straight line and you are applying the same force here. So, these two wooden blocks they have different masses. One is having larger mass, another is having a lesser mass here. If you apply same force on both the objects here, which will able to accept the change easily? Naturally, the lower mass object will move faster than the heavier mass object here. From that, we can able to tell inertia depends upon mass of the object. So, the higher mass objects cannot accept the change easily there. It can move very slowly there. So, inertia depends upon mass of the object here. Suppose we have a 8 kg object and 25 kgs. So, have two spheres, one is of 8 kgs, another is of 25 kgs. Which is having more inertia? 25 kgs will have more inertia, while it is having more mass. So, inertia depends upon mass of the object here. So, today we are going to know about Newton's second law of motion. So, in Newton's second law of motion, we are able to know that the net force acting on object is not equal to 0. Yesterday what we have learned here, in Newton's first law of motion, net force is equal to 0. But in Newton's second law of motion, you are using a non-zero net force acting on the object. So what happens when the non-zero net force acts on an object? Naturally, the object have an acceleration. Whenever you are applying a force on the object gets accelerated. So force is the action and acceleration is the producer on the object here. So basing on that, Newton he has explained the second law of motion. So today's topic is Newton's second law of motion. In Newton's second law of motion, the net force is not equal to 0. So, whenever net force is not equal to 0, the object gets accelerated. You will have acceleration produced on the object here. For that, you are able to give an example here. Suppose if you place a ball on a veranda like this here. It is in the state of rest here. Whenever you apply a force, a net force on the object, then the ball moves with accelerated. It moves very fast here. So there is nothing but whenever you are applying a force, the object changes its position. So acceleration is produced in the object here. Basing on this, you are able to have Newton he has explained about the second law of motion by having a concept here. Here you have different objects here. So you are applying a force on the same object here. So for one marble, both marbles having same mass here, and you are applying a different force for that one. So first marble is applied with a smaller force, so it will have a less acceleration. And on the second marble, if you apply a large force, it has a more acceleration. It will have a greater acceleration. From this, what you can able to understand, acceleration is directly proportional to applied force here. So, A is denoted for acceleration. Acceleration is directly proportional to applied force here. So, when force increases, acceleration also increases. That is the activity here. So next one is you are using a different mass objects here. So one is a heavier mass, another is a lower mass here. So if you are applying the same force for both of these objects, this smaller object which is having a less mass, it will be having more acceleration. When you are applying the same force for both, the small object will have a more acceleration, and the same force is applied for a larger mass, that larger mass will have a less acceleration. From this, what you can able to understand, acceleration depends upon the mass of the object, that is inversely proportion. Here, acceleration is inversely proportion to mass of the object here. So here, A is acceleration, F is applied force. Here A is acceleration, M is mass of the object. So acceleration is directly proportional to applied force, and acceleration is inversely proportional to mass of the object here. So for heavier mass objects, you have a less acceleration. Whenever you have a lower mass, acceleration will be more. So basing on this concept, you are able to get acceleration. Whenever you combine these two equations, you can take this as equation 1 and this is as equation 2. So if you combine these two, you are able to get acceleration is directly proportional to applied force and inversely proportional to mass of the object here. If you remove the proportion, you will get a constant here. Acceleration is equal to a constant called proportionality constant K, F by M you will get here. When the value of K is equal to 1, whenever it is becoming a unity, then you are able to get here acceleration is equal to F by M. So you will able to get a formula here, F is equal to MA. So this is the formula given by Newton. Force is equal to product of mass and acceleration. F is equal to ma. So acceleration, what Newton's second law states here, acceleration is directly proportional to applied force and it is inversely proportional to mass of the object here. So basing on this, Newton has derived the formula force is equal to a product of mass and acceleration. So what are the units for mass here? The units of mass is kilograms here. So for mass, unit is kilogram. SI unit of mass is kilogram, and SI unit of acceleration is meter per second square. So kilogram meter per second square, that is the SI unit of force here. This kilogram meter per second square only called as Newton. So SI unit of force is Newton. It is denoted with capital N. Or if you are able to write in words, you have to write in it starts with a small letter N here. So Newton. So SI unit of force is Newton. Now basing on this, Newton we explained this second law of motion on another concept called momentum. So linear momentum is the concept given by Newton, and basing on that momentum, you are able to get the formula F is equal to ma. First, you have to know what is momentum. So for that, we have examples here. Suppose a heavy loaded vehicle and a cycle, whenever they go on to strike a wall here. So you have a heavy loaded vehicle. Another is a cycle. So whenever this both go and strike a wall with the same. So you have two vehicles. One is a heavy loaded lorry and another is a cycle. Both they are moving with the same speed. Whenever they hit a wall, which gets damages more, which will damage the wall more? Naturally, this vehicle, heavy loaded vehicle, lorry, will damage the wall more here. So that is nothing but a more mass object will damage the wall here. So whenever you have a heavy mass, it is able to damage the objects here. Similarly, if I just throw a bullet towards the wall here. So it won't damage the wall here. And same bullet whenever placed in a gun and it is fired to the wall, then it will damage the wall. Why means that fast moving bullet which is having more velocity, it will damage the wall here. So one is velocity, a fast moving object and a heavy loaded object, both they are able to damage the object here. So from this concept, we are able to get momentum. So momentum is nothing but a product of mass and velocity. So momentum, it is denoted with P, with the letter P, and you are able to get a product of mass and velocity. So m is mass of the object, v is velocity. So momentum is nothing but a product of mass and velocity. This velocity is a vector quantity. Already we have learnt about scalars and vectors in chapter 1. So velocity is a vector quantity. So momentum is also a vector quantity. So what are the SI units for momentum? For that, basing on this mass, the SI unit of mass is a kilogram. And velocity is a meter per second here. So kilogram meter per second, that is the SI unit of momentum. Or we have another unit can be known here is Newton second. So Newton second is also another unit of momentum. Kilogram meter per second or Newton second, that is the SI unit of momentum. So basing on this concept momentum, you have Newton's second law of motion. So applied force is directly proportional to rate of change in momentum. So that is said to be Newton's second law. You are able to explain Newton's second law in two forms. One is acceleration is directly proportional to force and it is inversely proportional to mass of the object here. Similarly, you have another one is applied force or net force is directly proportional to rate of change of momentum. So basing on this, we have Newton's second law of motion. See, net force is directly proportional to rate of change in momentum. This delta P is called change in momentum with the time interval. So change in momentum with the time is said to be rate of change in momentum. So net force is directly proportional to rate of change in momentum. Delta represents change here. So change in momentum. So we are able to write here F net is equal to, if you remove the proportion, you are able to get a proportionality constant K into delta P divided by delta T. So here, if you are observing the momentum SI unit is Newton second. Time unit is seconds here. So that SI unit of force and SI unit of the momentum and time, whenever both are of the same, we are able to get the K value as a unity. So when K is equal to 1, we are able to get applied force F net is equal to delta P by delta T. So we know very well momentum is a product of mass and velocity. So momentum is equal to mass into velocity product here. So you are able to write here F net is equal to, in place of P, we are able to write mass into velocity divided by time here, delta T. We know very well mass is constant everywhere in the universe. So mass can be changed to other side here. We are able to get here mass into delta V by delta T. So this is nothing but delta V by delta T is nothing but rate of change in velocity. Rate of change in velocity delta V divided by delta T is nothing but called as acceleration. So in place of delta V by delta T, you are able to use here the letter A, acceleration. So F net applied force is equal to product of mass and acceleration. This is the formula derived by Newton in his second law of motion. So applied force is equal to product of mass and acceleration. M into A. F is equal to ma. That is the equation, a formula derived given by Newton here. So this is about Newton's second law of motion. Using this Newton's second law of motion, another scientist he has prepared a machine called Atwood machine. So that is used to verify Newton's laws of motion. So next concept is about Atwood machine. So to verify Newton's laws of motion, a scientist Atwood he has given a machine called Atwood machine. So Atwood machine consists of a small wheel called pulley connected to the ceiling, and it contains an extended inextensible string here. At the ends of this string, you are connecting two loads M1 and M2. We are considering M1 is greater than M2. So these wooden blocks, M1 is having greater mass, M2 is having a lower mass here. Whenever it is connected to the string, this heavier mass object it comes down with an acceleration A. Similarly, lower mass it goes upwards with the same acceleration A, and it have a tension here acting on the opposite direction to the gravitational force here. So basing on this, if you apply the free body diagram for the load mass M1, you are able to get here mass M1. Upon this, two forces are acting here. One is the weight of the object M1g, another tension is acting in the opposite direction. We know Newton's second law, it has given F net force is equal to mass into acceleration. Here mass you are considering M1, so you will get here M1A. And basing on applying this forces here, free body diagram for this force, here M1g is more greater than T, tension here. So that only object is coming downwards. So it is getting accelerated in downward direction. So you can able to tell here the net force is nothing but M1g is greater than the tension. So net force is nothing but M1g minus T is equal to, you get M1A. So basing on this, you can able to get here, you can write here M1g minus M1A is equal to T tension. This you can take it as equation 1. This comes from a free body diagram for a load M1, mass M1 here. Similarly, if you observe for free body diagram for the mass M2, you are able to get here this mass is moving upwards here, and whenever it is moving upwards, tension is greater than weight of the object here. But here what you are able to observe, here weight of the object is greater than tension. So you are able to write here M1g minus T here. But in this, by applying the Newton's second law of motion, F net is equal to mass into acceleration. Here mass is M2, so M2 into A will get here. So what is the net force acting here is, we have two types of forces acting here. One is weight of the block, another one is tension. So basing on this, you know very well, this M2g is less than the tension. So that only it is accelerated in the upward direction. So here we are able to get T minus M2g is equal to M2A you get here. So here T is equal to this minus M2g, if you send to other side, you will get a plus here. So M2A plus M2g. This is a second equation. So by solving this first and second equation, you are able to get the acceleration. How much acceleration is acting here and what is the tension acting here. So by calculating, by solving these two equations, you are able to get the acceleration there. So from equation 1 and 2, if you observe here, both sides you have a tension here. So you can able to equate M1g minus M1a is equal to M2a plus M2g. So from 1 and 2, from equation 1 and 2, you are able to get here M1g minus M1a is equal to M2a plus m2g here. So if you just transpose these terms here, you are able to send this m1 here minus m1 to other side, and you can send this m2g to the left hand side here. So you can able to get here m1g minus m2g is equal to minus m1a. If it comes to right side, it will become a plus here. So you get m1a plus m2a. In this, you are able to observe your acceleration due to gravity g, that is a constant here. So if you remove the constant term here, g outside, here inside you get m1 minus m2 here. Here you are able to get here acceleration is a constant here. So if you remove the constant term outside, here you will get m1 plus m2 here. So if you just common term here is the acceleration. Here common term is a g. So if you remove the g as a common outside, you are able to get m1 minus m2. If you just remove the common term here a, you get m1 plus m2. From this, you can able to get here m1g minus m2 into g divided by m1 plus m2. This is equal to acceleration. So from this, you are able to get acceleration is equal to m1 minus m2 into g divided by m1 plus m2. So this is the formula given by Edward for deriving the acceleration, for finding the acceleration. m1 minus m2 into g divided by m1 plus m2. So if you know the mass of the wooden blocks and g value is constant, you can able to take 9.8 meter per second square, or you can take sometimes in problems they used to give us 10 meter per second square. So if you take the value of g constant, and if you know these values m1 and m2, you are able to calculate the acceleration of the wooden block. Similarly, you can find out the tension acting on the object here. If you put the value of a in any one of the equation, you are able to get the tension here. See, from this acceleration value, if you put in the equation 2, t is equal to m2a plus m2g. From the second equation or first equation, in any equation you are able to substitute here. So if you put here m2, write down as it is, a value you have to put this acceleration value here, m1 minus m2 into g divided by m1 plus m2 here. This plus m2g. So m2g divided by 1. This is nothing but you can able to write if you don't have any value, you can keep it as 1 here. So here if you take LCM here, you are able to get here m1 plus m2. And here you are able to multiply this terms here, m1 m2 into g. You get m1 m2 g. Here minus m2 into m2 square into g plus 1 into m1 plus m2 into this value here. So you get m1 plus m2 into m2g. So from this you can able to get tension is equal to m1 m2g minus m2 square g plus here m1 into m2 will get m1 m2 into g plus here m2 into m2 square g divided by m1 plus m2. So from this you can able to cancel. If you observe here minus m2 square g, here plus m2 square g, these two terms gets cancels. Here you are able to get m1 m2g. Here in front you can write coefficient as 1 plus here also m1 m2g divided by m1 plus m2. So coefficient we can able to place it here as 1. So in both you have the common terms m1 m2g and m1 m2g. If you both add here, you will get 2 m1 m2g divided by m1 plus m2. So this is the formula for tension. We are able to derive a formula of tension acting on the two wooden blocks here. So today's class you have learnt about Newton's second law of motion as well as applications of Newton's second law of motion that was given in Atwood machine. So tomorrow class we are going to learn about Newton's third law of motion. Thank you.